All right, I must ask you a question. Sorry. When sodium is excited, it emits yellow light with a wavelength of 589 nanometers. What is the energy per photon of this light? All right, so right away, I boxed the energy because that's what we're looking for. So we're going to be looking for what the energy is for this photon, which is just a packet of light. Um, all right, so we have equation number one gives us energy equals hv. So E is the energy, H is arg Planck's constant. Sorry again, and that V is going to be our frequency. So we have E equals hv, right? So let's see what we can sub in here. So E is energy. That's what we're looking for. Planck's constant, so it's a constant, so it's always going to be that number. So it's always going to be that 6.63 times 10 to the negative 34 joules times second. All right, so it's always going to be that. And that's going to be multiplied by our frequency. So do we have our frequency? No, we don't, right? So it's not given to us in the problem. They do give us wavelength, though. So let's go and take a look and see what our second equation has for us. So let's go ahead and change colors, too, while we're at it. Let's go with green. All right, so our second equation is C, which is the speed of light, equals wavelength times frequency. All right, so speed of light is another constant. It's going to be 3.0 times 10 to the 8th meters per second. All right, so, and we're given wavelength in our problem, right? This is something I underlined earlier. So wavelength is 589 nanometers, and we don't have frequency. So we are given two of the three variables, so we can go ahead and use that to solve for what V is. So let's go ahead and write down this equation. So we have C equals that weird wave and the V. All right, so we're given two of the three variables. Because of space, I'm going to go ahead and rearrange this equation. So we're looking for the frequency in this part. So if we notice that frequency and wavelength are right next to each other, so if I want to isolate that variable, I can divide both sides by that weird wavelength. So I can get frequency equals C divided by wavelength, right? So I just did some algebra there. Nothing too fancy. I just divided both sides by the wavelength. So it's going to eliminate the wavelength on my right side and give me wavelength underneath that C. Now I'm going to go ahead and sub in what my constant for speed of light is, right? So speed of light, 3 times 10 to the 8th meters per second. All right, and they gave us wavelength is 589 nanometers. So before I can just sub this guy in, if we notice, this is nanometers, does not match up with my unit meters. So I don't know if this is before your time. It probably is, iPod nanos. Nano is just something super, super small, right? So 1 nanometer is equal to 1 times 10 to the negative 9th meter. So that's like we have to move our decimal to the left 9 times. So it'd be a super, super small number, 0.0019. But we can leave this in scientific notation. So all we're going to do is we're going to put 589 times 10 to the negative 9th meters, right? So now we have this super small number compared to this much larger number, which colored light is usually measured by nanometers because of just how small those wavelengths are. All right, so now we can go ahead and just finish solving for our frequency. So I'm going to flip back over to that green. So we're putting in our handy dandy calculator. 3 times 10 to the 8th. And then we're dividing it by, 589 times 10 to the negative 9th. All right, so we are working with some scientific notation. So if you're having trouble with scientific notation stuff, I'm going to plug in the comments or in the description just a couple of links of how to use scientific notation. So in your calculator, if you're having trouble with it. So I'm going to get 5.093 times 10 to the 14th as my frequency. And if I want to look back at what my units for frequency is, it's per second or hertz. I'm just going to use this per second. So S to the negative 1 is just telling us that it's per second. And that's going to make sense because our unit meters are going to cancel out, and we're going to be left with seconds at that bottom, right? So we see it that it's slashed. All right, so if our problem was asking for frequency, hey, we're done. But this is asking for the energy. So now we're given, or now we've solved for energy, so we can plug the energy back into our first original equation. So I'm going to go ahead and I'm just going to take my 5.093. So I'm going to write down 5.093 times 10 to the 14th per second. All right. Oof, that's looking lovely. So all we're going to do is we're going to take that number, and I'm just leaving it in my calculator, multiplying it by Planck's constant, arg 6.03, times 10 to the negative 34th joules per second. All right, so I got a number here. Let's see if we can change colors. So my energy I got to be 3.38 times 10 to the negative 19th. All right, my unit for this. The seconds are going to cancel out. I got that 1 second and then that per second, and that's going to be left with the unit J. If we look back over here, energy is always measured in the unit joules, which is just that J. So my answer for the energy per photon for this yellow light is going to be 3.38 times 10 to the negative 19 joules. All right, so that's my energy of my yellow light. We used both equations because in our problem we were going from wavelength all the way to the energy. All right, let me click my mouse here. I do want you guys to try one. So I want you guys to go ahead and pause the video, take a look at this question. The wavelength of green light is 522 nanometers. What is the frequency of this radiation? So you're going from wavelength to frequency. You're just going to need one equation. So go ahead and pause that video. Is it paused? Yeah, okay. So hopefully you paused it. Hopefully you tried that problem. And if you tried it, what you should have gotten is 5. Oh, embarrassing. Let's go ahead and get this blue color here. So you should have gotten 5.75 times 10 to the 14th per second, or you could say hertz, right? So per second or hertz. So if you did not get that, try it again. Take a look and see what you did wrong. I'll also post some help with that in the description. But otherwise, I'd love to stay in chat, but I really mustache.